Okay. Let's get ready for class. Oops, sorry. Brandon, let's get your homework out, bud. That 2.7 sheet. Don't you come straight from PE or something? It's not hot up here, you're just still cooling down, I'm sure. Please keep your mask up. Caroline, same deal.
Where at? Like, I'm at Guthries. I'm done on Sunday, and I have to go to BCH. To,
Drug test?
no, not interview.
Why?
Other interview.
We did the spray that we're supposed to
Summer
do
intern.
to clean the desk.
I'm nervous.
Drug test?
No, I don't have to get a test. It's not like I do drugs anyway.
False.
It's fine.
Gotcha. Oh God. We know our last day. Our Lord's life.
I really need to keep my phone on me.
Really?
Oh, shit, it's on.
Alright.
Loud.
What?
What?
What alarm was that?
It was number 19 and 20.
You already did that, didn't
As I said before, we've done all of these except we struggled on it, so we need to go over.
Why do I have two?
He just said.
Because we did it, and then we struggled on it on the understanding check, so we're going back over it to make sure we learn it before the understanding check.
I was about to say, I pulled out this and had nothing on it. I was like, I screwed, swore I did something.
I need to get this out so we can go over it. Alright, we're going to go over a couple of things to get this kicked off before we start the understanding check. First things first, what are the two methods, or what are the two forms that we can represent a root with?
Radical and exponential.
Radical and exponential. They mean the same thing, but do we approach the problems exactly the same way?
No.
We all comfortable with that idea?
Yes.
Okay? Now, with our exponential, you have to remember your exponent rules. With the radical, you have to remember the radical rules, which there's not as many of those. So in some ways, it's way more, or not way more beneficial, but way easier to work with. You have to choose which form you work with. There are some on the understanding check. You've already seen it. There are some on the understanding check where you start with radical form. Does that mean you have to simplify it in radical form? Caroline, do we have to simplify in radical form?
Yes.
Is your name Caroline?
No.
I didn't think it was. Caroline, do you have to simplify in radical form?
Yes.
No.
I'm sorry, I really wasn't paying attention.
See,
Need you to pay attention. I also need you to keep your mask up over your nose. I need y'all to remember this. I mean, you can be upset. We literally got an email, all teachers did, about making sure that students keep their mask up. And that teachers make sure that they wear their mask, which I assumed everyone was, but everyone needs to be wearing masks at all times. It doesn't matter how you feel about COVID-19 or the pandemic or whatever, like,
I think it's a hoax.
you may feel that way.
Obviously, it's not if everybody up here dying.
Mona, please keep your mask up over your nose
Yeah.
as well.
Okay, I'll keep
Look.
it. But yeah, okay, wrong.
Hey,
Okay, it was
hey.
an opinion.
hey, Alan, Alan,
Sorry,
are you in charge of this classroom?
no, sorry, sure.
Let me handle it.
No,
all right.
sorry.
We're so busy fighting with each other that we're not taking the time to actually learn and grow. But here's what I do need you to understand. Like, the rules right now are in place that we wear masks. It doesn't matter how you feel about it. This is trying to help protect people. And I will be the first to rejoice when we don't have to wear masks anymore. But in the meantime, be responsible and look out for other people. Life isn't all about you. And we need to understand that. If there is a way that I can protect other people, I'm going to do the best that I can to protect those people. So, we need to recognize that you can use either radical or exponential form. And we're going to do both for both of these up here. And what I would recommend is you pay attention and you take some notes as we go over these. If you need a separate sheet of paper because your paper is full, there's free paper up here. But I promise you, the more that you write it down, and I can slow down if you need me to, the more you write it down, the better you'll remember it. There is a connection in your brain that when you write stuff down, your brain remembers it better. That is a proven scientific fact. Psychologists have studied it for years. So, more of us need to pick up pencils, be ready, and have space to write this stuff down. Number 19. How would I read this?
Fifth root of.
You can stop there, I'm okay with that. I just need you to recognize that's a fifth root, yeah?
Yes.
So if I'm working as a radical, which we are going to simplify this as a radical first, it is a fifth root. What exponent do I want since it's a fifth root?
5.
It's not a mystery. Don't make it harder than that. If it's a fifth root, the exponent I want is a 5. Now, we're going to handle the variables in a second, but that means when I look at these coefficients, I want it as some base raised to what power, if at all possible? 32, I can rewrite it.
Oh.
As what, I want it as some base raised to what power?
5.
A 5. That's it. Please keep your stuff. Ooh, Zay, I'm sorry I didn't see you there. I just thought it was on. It's my bad. Gentlemen, we are going over the last two problems off of 2.7 quickly before we take our understanding check, and we need to move quickly. So, does anyone have an idea how I could factor that 32? Just anywhere I could start with my factors.
2.
2 and?
Oh.
2 times what gives me 32? 16. There we go. Can't factor 2 anymore. At least the only factors would be prime numbers. How could I factor 16?
8.
8 and 2. Still can't factor 2, so I'm going to stop there. What about 8?
4.
Can't factor anything else.
2 and 2.
Well, 4 become 2 and 2. Notice how many 2's do I have?
A lot.
5.
5, which is convenient because which root am I dealing with?
5.
Fifth root.
Fifth root, right? That the index is a 5, but the root is a fifth root. So I'm going to rewrite that 32 as 2 to the fifth. I want it as a base raised to the same exponent as my index. Is that clear? Then when I look at x to the 13th, because I have 13 x's, are there any ways that I can break that up so that the fifth root cancels with it? So if I do x to the fifth times x to the fifth, how many x's do I currently have? 10. See how that exponent is the inverse of the root, right? Do I need any more x's though to get that x to the 13th? I also need 3 more x's. That's only 10. I'm supposed to have how many? 13. So I need how many more?
3.
Again, 243, I want to factor it. When I factor it, I want what kind of exponent? a 5, if at all possible. Any guesses what factors there are for 243?
No.
Not even a guess?
32 and 4.
Okay, so pick up a calculator. 32 times 4.
False.
False, that is not giving me 243. Give me another guess.
Human calculator.
Remember with 32, you started with a 2 and 16.
64.
Does 2 go into 243? Okay, focus up here. How do you know it doesn't go into 243? Huh? It's an odd number, right? It's odd. An even number can't go into an odd. Okay, so what's the next number after 2 that I could try to divide into it? 3? 3 times what gives me 243? You can also pick up a calculator and do 243 divided by 3 to figure it out.
5. I mean, no, 5.
We want an exponent of 5.
Yeah.
81.
81. By the way, notice we have a 3 now. Does anyone want to take a shot in the dark? What this is going to be right here? What to the 5th?
3.
It's probably going to be a 3 to the 5th.
Mm-hmm.
So let's check. Obviously we can't factor the 3 anymore. 81. 9 and 9.
3 and 3.
Hey, how many 3s do I have?
4, 5.
5 of them. That's real convenient. It's like someone created this problem to make my life easier. We just have to understand we're looking for a 5th root. It makes things significantly easier when we pay attention to that. Y to the 15th. Again, what exponent do I want? The 5th, right? Or a 5, an exponent of 5. So how am I going to break y to the 15th up? If you understand that I want a 5th power, then you just keep doing it until you get to the exponent that was already there. And then you just have to distribute your radical. That's it. Distribute that radical. The 5th root of 2 to the 5th times the 5th root of x to the 5th times the 5th root of x to the 5th times the 5th root of x cubed. Now, this is why I prefer rational exponents right here, because I hate doing this distribution. But does it work?
Yes.
Yeah. Is it an efficient method that will always get you there?
Yeah.
Heck yeah. Okay? So then we also have the 5th root of 3 to the 5th, 5th root of y to the 5th, 5th root of y to the 5th, and 5th root of y to the 5th. Why did I want an exponent of 5 on all these?
Inverse.
It's the inverse of a 5th root.
Yes, sir.
So does that cancel?
No.
Nope. So all those exponents, all those roots, those radicals are now gone. So I'm left with a 2, x, x. What is x times x?
2 squared.
There we go. Do I still need this 5th root of x cubed?
Yes. Can you make that?
Make it what?
I want to say x to the 3 squared.
Say it one more time.
X to the 3 squared.
Heck yeah, you can. Right? Remember, x to the 3/5. That is still the 5th root of x cubed, isn't it? So 5th root of x cubed. Totally valid. You can do that. I'm totally okay with that. That ties in more to us approaching as an exponential form, but that is valid. Now in the denominator, 3 times y times y times y.
Y to the 3rd.
There's my answer. Factor it out so that your exponent matches your index. Then you distribute your radical. That's it for a radical approach to roots. Okay. Now, what I do want to show you is my first step for an exponential form and for approaching with a radical form is exactly the same. I always deal with my coefficients first. I would first write this as the 5th root of 2 to the 5th, x to the 13th, divided by 3 to the 5th, y to the 15th. That is going to be my first step, even when I'm approaching it in exponential form.
So the number in front of the variable is called a coefficient?
Correct.
Okay.
The number in front of a variable that's being multiplied by the variable is called a coefficient. Okay? I feel like we didn't need to go back through all that because we just did 32 and 243. Is that fair?
Yeah.
You comfortable with that idea?
So we still don't, wait, what you gonna do now?
Say it one more time.
What are you about to do now?
Well, so remember, we already did this root as a radical. Now we're going to do this same exact root as an exponent.
Okay.
We all good with that idea?
Yes.
Now, there's two different ways you can approach this. You could do this as 2 to the 5th, x to the 13th, divided by 3 to the 5th, y to the 15th, all raised to what power? What exponent? The 1/5. That is still a fifth root, is it not? Good with that idea? And actually, that's probably what I would recommend. Now, when I raise a power to a power, what do? Multiply the powers. This is why I always rewrite my coefficient as a base to a power first, because a lot of people forget to distribute that to the coefficient. But this way I don't forget that because I have powers there. But notice that would be 2 to the 5 times 1/5, x to the 13th times 1/5, 3 to the 5 times 1/5, y to the 15th times 1/5. Raise a power to a power, so I distributed them. Any questions about that before we move on?
Hold on, I'm ready.
Oh, so you just leave it at that?
Not quite. You have to multiply.
Yeah.
But what is 5 divided by 5?
1.
It's like that fifth root and that fifth power cancel each other.
Yeah.
Oh wait, that is exactly what happened. Right there. Now, I can't just cancel here. So I'd have to leave it as 13 divided by 5. We'll handle that in a second. What is 5 divided by 5?
1.
1, right? It's like, again, that fifth root and that fifth power canceled. What's 15 divided by 5?
3.
Is that so far pretty similar to what we had?
Yeah.
It's your choice which one's easier, but that's how I would approach it. Now I do need to handle this 13 divided by 5. This is the one tricky part, which if you don't like this part, deal with radicals. But all I'm going to do is I'm going to take my 13, I'm going to divide 5 into it. How many times does 5 go into 13?
No. 2.
Twice. Take away that 10, what's the remainder? So now I'm going to write this as 2x to the second plus 3/5. That's my 13/5.
You leave it like that?
Nope, you're very close to being done though. When do you add exponents?
And then multiplying.
So that could be written as x squared times x to the 3/5. Remember earlier, Donovan, when you asked could we rewrite that as the x to the 3/5, the fifth root of x cubed? So are these expressions exactly the same?
Yeah.
Does it matter whether you do it as a radical or as an exponent?
No.
But you need to be comfortable with one. And if you prefer radicals, you have to know how to convert from a rational exponent to a radical. If you prefer exponents, you have to know how to convert from the radical to the exponent. But it's best if you know both, so that whichever one you start with, you can work with it. Again, big picture idea. If you're dealing with radicals, you want to factor it so that the exponent is the same as the index. And then distribute your radicals. If you're working with it as an exponent, really just multiply those exponents. And then simplify it right away, but if you do get left with some ugly fractions, you just divide. And then you can split up the powers. Now I do want to remind you, I'm not going to spend a ton of time because we've got to get to the understanding check. When I look at this, I read this as the square root of 9 cubed. What's the square root of 9?
2. 3.
3. I don't even have to do anything else. I already know that the square root of 9 is 3. What's 6 divided by 3? 2. Language. Figure out what works best for you, but notice, I thought about it somewhat as a radical, but by understanding those as square root, it sped everything up significantly. Are there any questions before we go back to the understanding check? Does this help us a little bit more moving forward? Hopefully we see improvement, but also, ladies and gentlemen, y'all engaged with me a whole lot more than you did with Mr. Lipum yesterday. You talked, we had discussions, and I felt like I could see in everyone's eyes that you felt like you were learning. When you talk and when you engage and you discuss the mathematics, you will learn more. I need you to actively be engaged the whole time. We can't control that for you, only you can. And when you do that, you will find significantly more success. Now, what I'm about to do is I'm actually about to give you the old understanding check that you already started, which I have graded. There's a little bit of feedback on there. I'm also giving you a blank one. You write your answers on blank one, but you can use your old one to help you a little bit. Make sure there is at least one desk in between you and anyone else in your group, so someone in this group needs to move. Yes. Please put up your 2.7.
Oh my god. Sit right there. So I don't understand. What's your real next name?
You want to do work with Miss English? Your choice. Y'all have 25 minutes to get this understanding check done. Once you finish that, you need to get your get a computer and log in. Yes, sir. It's an understanding check. Now, at the same time, if you improve your understanding and learn from this before the test,